Hello kids, today's lecture is on momentum, which is a new variable for us and sort of the basis of this next unit on conservation. Okay, so you've all probably heard the word momentum before, so take a second and try to think of an example of something that has a lot of momentum. Often when I ask this question, one of the first things that comes to people's minds is a large football player, and I think that's probably a pretty good example of something with a lot of momentum. But the football player doesn't have the most momentum, as you can imagine. If you wanted to pick something that had even momentum, you could think of something bigger and faster, maybe something like a train. So train definitely has more momentum than the football player. How about something bigger and faster than the train? Something like a flaming blue asteroid. Yeah, that's got a lot of momentum. Okay, now how about objects that don't have a lot of momentum? Kid on a trike. I think we'll all agree that's an object without very much momentum. But there's even objects with less momentum, something even smaller, something even slower, like, for example, this hamster running on a wheel. Even less momentum than the kid on the trike. How about something with even less momentum? Something like maybe this pea sitting on the ground. Yes, this pea really has very, very little momentum. In fact, you might even say it has no momentum. Ha ha ha. So based on those examples that we came up with, what are the variables that impact the momentum of an object? Well, obviously the size of the object had something to do with it. We already have that variable, its mass, and it's m. Incidentally, you might want to open up your notebooks to the variables page so you can add information about these variables that we don't know yet. The second variable that impacts momentum is the velocity of the object, which we were sort of saying how fast the object is moving. In your notes, you should write velocity down as a new variable. The symbol that we use to represent velocity is a lowercase v, and the definition is how much distance an object travels every second. The units of velocity are meters per second, so it's meters every second, or meters divided by seconds. One note about velocity, you can have positive or negative velocity. So I think that that's a little different than maybe what some of you guys might picture. If I say something's moving at negative 40 meters per second, that just means that we're moving in the opposite direction from what a positive 40 meters per second would be. And at the same overall speed, we're covering 40 meters either way. It's just that if we're going positive 40 meters, we're going 40 meters in the positive direction every second, and negative 40 meters per second is negative 40 meters every second. So momentum, what is momentum? We've been using it a lot, but what does it actually mean? Well, momentum is defined as how much sort of oomph a moving object has. It's not a great definition. Some people call it the quantity of motion, which is a little bit weird to me too. But I tend to think of it as you know, how hard something would hurt you if it whacked into you, or how much bang for your buck an object is going to have. Now, strangely, the variable that we use to represent momentum is a capital P, probably because we already used m for mass, so P is momentum. And the units of momentum are the kilogram meter per second. So kilograms and meters on the numerator divided by seconds on the denominator. And just like velocity, the direction of the momentum matters. If you have positive momentum, it means it's moving in a positive direction. It's going to whack you in the positive direction. If you have negative momentum, it just means that the object's moving in the negative direction. There are two relationships that go into calculating momentum, as we probably saw in the earlier slides. For one, the larger the mass of the object, the larger the momentum is, which means that there's a direct relationship between momentum and mass. The second relationship is that the bigger the velocity an object has, the bigger the momentum is. That means there's a direct relationship between momentum and velocity. And one little subtle point here, negative 50 is a bigger number than positive 20. So we're worried about the actual magnitude of the number, not the sign. So even though you're used to a negative number typically meaning small, in this case, the positive and negative doesn't determine how large or small the number is. It just determines the direction. So it's the size of the number itself that determines how large the velocity or the momentum of the object are. So we can use those two individual relationships to come up with an equation for momentum. Just like we've talked about in class, two direct relationships mean that my equation will look like this. P is equal to mv. Momentum is equal to the mass of an object times its velocity. If you think about the units for these variables, you'll remember that the units of mass are kilograms, units of velocity are meters per second, so if you multiply those together you get kilogram meter per second, which is the unit of momentum. So one practice problem for you to think about on your own before you come to class: how much momentum does a kid on a tricycle have? Come to class with a reasonable estimate and see if you can use units all the way through your calculations. Okay, thank you.